Okay, so now that we have looked at how to purify our metal and get it to its final usable form, let's also look at what problems we face whenever pure metal is being used by us in daily use. Now, it's a very common thing for us to notice that iron things that are put outside are going to start rusting. Right? We call it rust. It just kind of just gets powdery brown. And you'll also notice if you have silverware, over time it just kind of gets this greenish layer or kind of just also could go black. So all of these are ways that whenever a metal is exposed to the elements, it's going to get affected in some way. And we call this as corrosion of metal, right? It basically ruins the metal in such a way that it cannot be used for what we want. So this corrosion is something that we have already studied, I guess, previously also. We also commonly call it as rusting, although that's more typical of iron that we call it as rust. Now, what exactly is this corrosion? We already have a fair idea. We know that whenever there is moisture and air available, then a rust will occur. The actual process behind it is a little more complicated than simply just oxygen reacting. We'll just take a quick look at what the corrosion mechanism looks like. Okay, so say there is a metal, a piece of metal, like let's just take iron, right? So because say you have a big slab of iron over here. So over time, what happens is at some spot in your iron, there's going to be a slight electrochemical process happening over here. So it is kind of like electrolysis in how you will see. Okay, so at one spot, what happens is this iron or a couple of atoms of this iron are going to get oxidized. Okay. Now remember that oxidation has two definitions. One is gaining oxygen, the other is losing electrons. So this iron is going to lose electrons, become an ion of iron, and lose these two electrons. Now we know that electrons get conducted in a metal very easily, right? Since these two electrons are now free, they just like keep running around the entire piece of metal. And at some point, they are going to go through another reaction. Okay, this is where these electrons are going to get used up. So that reaction is nothing but the reaction with oxygen that's present in the air. So now what these two electrons will do, they'll react with the oxygen along with also some hydrogen ions that are present in the air. Right, these hydrogen ions typically come because of any acidic oxides that are present in the air, or any different methods that you can, different reasons you'll find these hydrogen ions, but typically they will be present, right? So you have four hydrogen ions, I think, and I think how many electrons? Four electrons you will need. Now, once all of these react together, you'll actually get 2H2, right? Water is being produced. So your entire, if you combine both of these reactions happening together, you'll see that the iron comes out as an ion and also water. Now again, in combination with this iron, which is Fe2 plus, gets converted to Fe3 plus. This is called a ferrous ion. This is called a ferric ion. Okay, so ferrous to ferric. Once this ferric ion is available, what happens is this ferric ion is going to interact with oxygen. This is the one that creates the iron oxide. So there will be this formula that we've seen, Fe2O3, right? So this Fe2O3 is nothing but the ferric combined with the oxygen dot some amount of H2O. Okay, how much can differ from, depending on the conditions, but say some amount, some X H2O. How much that excess can differ depending on which sample you're looking at. So this is like in a nutshell the entire process of oxidation. Okay, all these extra electrons would be contributing to the whole process. So like you see, each ion is going to contribute 3 electrons each on each side. Now, since this is a problem as such for us, corrosion, how do we avoid it? Because say if you have like buildings and bridges that rely on strong metals to stay sturdy, how do you avoid it? It's simple. By trying to coat the surface. You try to just make sure the metal does not touch the air, because that is where everything comes from. The oxygen, the hydrogen, all of that is coming from the air. So you simply try to coat it with either a layer of paint, which is a very simple process that all we do it with for everything that we own. You could also coat it with another metal. Okay. When you coat it with another metal, you either coat it with a metal that is passive, which means it is non-reactive, so it kind of just creates a barrier between the air and this thing, or something that is more active than your actual metal. We also call this as sacrificial. So since it is a more active metal, it kind of gets sacrificed. It will get oxidized, but your original metal, the ion below, is going to stay active. Some example of a passive metal would be tin, or what we call as SN, and something of this would be zinc, right? So that's all about corrosion, and that's all for today. If you have any questions, please drop them in the comment below, and I'm going to see you in the next class. Thank you.